Hello, hello. Welcome to the Good Garbage Podcast. My name is Ved Krishna. My primary reason for existence has been to find ways to leave our wonderful planet cleaner. We will be speaking with material innovators, creators, and propagators to learn from them how we can build for scale and towards a regenerative future. The idea behind the conversations is to explore ways in which our waste materials generate life. Their stories will help us answer the big question, what is good garbage? In our second podcast, I was delighted to welcome my friend and Mycelium wizard, Gavin McIntyre. He and his partner, Eben, have literally been growing their baby Ecovative designs into creating a set of applications from Mycelium, from protective packaging to structural materials. This is a wide-ranging conversation around the ideas of how nature can inspire and the magic of mushrooms. Enjoy. Hello, hello. I'm so happy today to have my friend Gavin McIntyre from Ecovative join me on this conversation. So I want to start, Gavin, with a little bit of backstory and how we met and, the journey so far so that, we can recollect it. So back around 2012, we started our journey on trying to find solutions, and we found this amazing group of people in near Albany doing amazing things with mycelium. And of course, we realized that styrofoam was such a big issue, and I hounded them for a while and finally got through to them. And I literally took a flight from India to New York and drove up to Albany, and it was just the most wonderful meeting, Gavin. I think each time I've met you, I think your kindness and your energy shines through. I can literally feel you sending kindness. So that's what I carry when I think of you, and it always brings a smile. So I'm just super excited about learning from you today and having this opportunity to converse on materials and packaging. So welcome, Gavin. Thank you for agreeing to be on the show. I know you have a busy life right now with family and work, but thank you so much for being here.
Oh, it's my distinct pleasure. And the feeling is absolutely mutual, the time that we've had to spend over nearly a decade together at this point. So I'm glad to be here and have the opportunity to speak with you today.
Thank you, Gavin. So I'm going to start. My first question is going to try and take you back a little bit in time and think about your earliest memories for packaging in particular. And, if you can think about an incident that impacted you in some way and motivated you to take the path that you've taken in life, it'll be great if you can share something from your past.
Oh, certainly. Well, from the past, in terms of where we founded Ecovative in the beginning, this particular technology came out of coursework at Rensselaer Polytechnic Institute, where Eben and I were both studying mechanical engineering and product design. And we had an amazingly influential professor at the time, a gentleman by the name of Bert Swersey, who came not from academia, but was a professor of practice. He was a serial entrepreneur and had a number of medical device companies prior to entering his career within academia. And what was really unique about his course and how he taught his students was that he was focused on what he considered to be not doing nonsense. And what he challenged all of us to do was to go out and identify one of the world's most pressing problems and to create a technological solution. And you don't really have to worry about the marketing or business opportunity, because if you have truly identified a meaningful problem, there's inherently going to be a market behind it. And so at that point, what we were examining at the time, and this was in 2006, was truly the ubiquity of plastics. And at that time, this was before the dawn of hydrofracking, there was an increase in fossil fuel prices. Namely because these are increasingly more challenging resources to extract, and they're inherently extractive, damaging technologies to our planet. And upwards of about 10% of the fossil fuel resources that we consume within the United States today are allocated to things like single-use plastics, which is truly an egregious use of these types of resources, which are so damaging to the planet, which then at the end of their useful life cycle, which in many instances in the world of protective packaging is a very short period of time, do not passively return to the earth. And so looking at this meaningful challenge, the economic pressures and the environmental pressures, This is before the recognition of things like microplastics and the accumulation of these materials within our oceans, as an example. Uh, we really looked to nature at that time for inspiration because, of course, within nature there is no waste. These ecosystems have been adapting over millennia in order to not only create the energy sources they need from the sun, but then also to upcycle all of those resources, be it plant matter, into new life forms. And that's where we really began to hone in on mycelium as nature's inherent recycling system. Because mushrooms, which are the fruiting body of mycelium, or the fruit itself, are truly nature's recyclers. They're quite adept at taking any type of leaf litter and coarse woody debris and transforming that into the mushroom you may see growing out of the side of a tree. And so for us as engineers, we thought to ourselves, well, how can we adapt this environmental process into an industrial setting to take use or advantage of all of the byproducts that come from various industries, be it agriculture and forestry, which there are a tremendous amount of these types of byproducts, and transform them into a higher value product. And at that point, we were looking at a wide range of different types of plastic foam applications, because plastics are used in a number of applications, be it automotive components to the largest use, which is in building construction materials. But we saw the greatest advantage for this technology being in a field like protective packaging, where something could passively return to the earth and then be truly circular, get transformed into the next generation of plants at the end of its useful life cycle, and therefore then be providing value both in a new high performance product that then again does not have the meaningful or degrading impact on our planet or burden to municipalities, which tend to have to deal with these types of things at the end of life.
Yeah. So I actually want to take a further step back because I have a lot of questions around the process and all the inspiration I have from the work you've done. But I want to take a step back to things I don't know. There has to be something about Gavin, the person growing up, even before the, college life came about, something that troubled you or something that, impacted you in terms of packaging. So when I was asked this question, I actually realized that there was very little packaging when I grew up. Most of the things were actually not packaged, and you were buying your monthly supplies, taking your little bag and doing it. And then my first impact was with Tetra Pak. And when drinks started coming in boxes, we were just delighted because we could carry them. Earlier, it was all glass bottles and with the caps, and once the caps were off, you couldn't really carry them. So yeah, I don't know. I would definitely think you would have had some experiences growing up that you might remember in terms of packaging and the impact that had had on you.
Oh, very much so. And I'd say it's beyond packaging. My passion first began with just nature itself. So growing up, my parents on an annual basis would take myself and my younger sister to the national park system. And we grew up in New York, and it's not widely known. Most people think of New York City, but where I'm located in upstate New York, we're in the heart of both agricultural and forestry country here. And the vast majority of the state of New York is actually covered by state-managed forest. And so my passion for nature came out of the family camping trips and experiences that we got to see in terms of the natural wonders that are across the United States through our national park system. And even there, within the national park system, it's not uncommon to see the accumulation of waste and debris, because even though there might be opportunities to dispose of things properly, when you're camping, you inherently get things that come in pre-packaged forms, be it food and things of that nature. And that waste is not uncommon to find along a trail or at a campsite, where even though individuals are having the opportunity to live within nature, that respect isn't always present. And part of the issue, I think, and the challenge is that if we can design materials that are inherently compatible with our planet, we can eliminate the need for societal change, because societal shifts take a tremendous amount of time in order to garner momentum and then actually have a meaningful impact. And then the other thing that I'll elevate is that I've always been passionate about biology and engineering. I am the son of a biologist and an engineer,
Ah,
and I live at the intersection of those two fields, truly. And so growing up, I always had a mother that would point out the different natural artifacts that were around us in our everyday lives, and a father that would inquire principally in terms of my understanding of physics
hmm
in nature and why nature has grown in specific ways or thrives in particular environments, and how different animals have evolved in order to take advantage of their ecosystem. And I think that perspective was really powerful and important for me to say, how are we as humans currently not operating within the boundary conditions of the environment that has been here for millennia longer than we have? And how can we do better by adapting to our environment rather than forcing our environment to adapt to us?
And your parents must be so proud of you for having that intersection and taking it forward the direction you have.
Oh, I feel very fortunate to be the son of scientists. It had its unique challenges growing up, but I have had a very good childhood and amazing parents.
That's wonderful. So I actually want to step into the evolution of Ecovative because I've of course known you for a while, and the amount of stuff that you've dabbled in and the challenges that you have faced. Um, and it'll be just wonderful to hear more about how it has evolved because you talked about protective packaging, but I know that you've worked in numerous directions. How do you see the journey so far, and how do you see it going forward in terms of what you're doing at Ecovative?
Oh, certainly. Well, in terms of the journey to date, which it has been 15 years at this juncture, we have learned a tremendous amount, both around how to scale up bio-based technologies, around supply chains for agricultural byproducts, where you really have to build up a market for materials that had little or no recognized value at the time, all the way through to identifying what the best product market fits are for our technology over time. And so, as an example, one of the key learnings that we've taken over the last 15 years that we're applying to new technology that we've either recently brought to market or will be bringing to market in the not too distant future is truly around how we go from laboratory work and incrementally scale that in a conscientious way so that we can mitigate risk while ensuring that the product delivers the right quality and economic value. So, as an example, when we first started Ecovative and we started our initial operations for a prototype manufacturing line, we were very scrappy. So, we adapted technology that we bought used from everything from an asparagus blanching factory to a chocolate factory and some agricultural processes, and we married these together. That allowed us to garner the process learning that we needed to initially deliver our products to some Fortune 500 companies at the time, which were inclusive of Dell Computers and Steelcase Furniture, as an example, which gave us the right encouragement to then invest further into additional scale. What we did, however, is that we went from an operation that was producing, say, on the rate of about tens of pounds of products per hour, it's very small scale, to thousands of pounds of products per hour. And when you take that magnitude of a leap, there are new considerations from operations. We work in the field of biology, biological considerations that we had not forecast at the time, such that when we made those investments, the scale ramp took longer. We ended up having to reinvent a lot of technology that we could have adapted and purchased from the shelf, while trying to deliver larger volumes of product, which we were successful in doing so. It took us a tremendous amount of time and more cost. But what those learnings allowed us to do was to distill and simplify our technology, eliminate the process waste that wasn't important, make the process more robust so that it could then be transferred, which is then something that has become incredibly powerful for us over the last 4 years, where we have now extended our reach internationally, trained others, have reduced the equipment package and facility size such that this can now be a duplicatable model around the world, where today we have over 10 partners on 3 continents that are growing mushroom packaging products, leveraging local agricultural residue that they can source themselves, and producing the same quality product that we can here in the States, but in their own geographies. That's incredibly important as it helps reduce the embodied energy for transportation, as well as the cost, which is a critical consideration, as well as helps extend our reach where, as we're a small company, we can duplicate our efforts, both learning and the markets that we can serve through these types of partnerships. And where we've historically have been very inclusive with our technology, we have found that democratizing this type of product really helps us meet the needs of the industry and displace as much plastic as possible, which of course in the end is our mission as an organization.
That's amazing, Gavin. Like just thinking about, I'm just thinking about it with two scrappy youngsters out of college, like with no real experience of industry, and just taking it to the scale you have, because it's so easy to falter. And I know you've had your set of challenges along the way. The other thing I see as a constant, although you've dabbled with a lot of products on the finishing side, the one thing that has remained constant for you guys is mycelium. Like whether I look at your forays into food, or I look at your forays into structural material, it's ultimately guided by that one idea of mycelium, or inspired by that. So taking that idea of mycelium as this wonder material which has kept you rooted, but then you have catapulted yourself in numerous directions, experimenting and seeing where it fits better, and taking it forward. Why mycelium is a wonder material, and what keeps you rooted there? And what are the things that you have created, and what are the things you're excited about creating in the future? Both those will really help me understand more about your thinking.
Yeah, of course. I'd say what we have discovered over the last 15 years that uniquely differentiates mycelium from truly the rest of living materials and life itself is the fact that it does inherently grow structure that can be influenced during the growth process to create products that are intended. And so let me describe how this relates to the rest of the field of life. So if we think about the microbes that we employ for producing things like insulin, bacteria as an example, or beer, like yeast, these organisms are really adept at producing small molecules. These are molecules that we can capture, use for pharmaceuticals, even create types of bioplastics like polylactic acid. But when these organisms create these small molecules, they still lack structure. And so that means there are additional downstream processes that are required that have cost and consume energy in order to transform those small molecules into the finished goods or products that we as humans use. If we go up the complexity of life and we look at something like a tree as an example, trees are brilliant materials. They are used in our building construction applications all the time. Their mechanical properties are, in many instances, second to none in the world of biology. But the challenge with trees is that they're always grown in the shape of trees. And in order to use them in our everyday lives, we end up creating waste by transforming a wonderful tree that's been growing for years on end, typically no less than 7 years, into something like a 2x4. What's unique about mycelium is that it really falls at the intersection of these two areas, where it is a microbe. It grows at an exponential rate, and so it lends itself quite nicely to an industrial scale. But as it grows, it also creates inherent structure, meaning that as it's growing, it's not producing a secondary product, like alcohol as an example. It's growing its own body. And unlike a tree, which has a somewhat directed path, fungal biology allows itself to be manipulated by tuning either the environment or the nutrition that you provide it, such that we can grow products to the final or near net shape, eliminating any needs for post-processing, eliminating all of the additional embodied energy that would have to go into it, which allows us to be both environmentally very efficient and economically efficient. So it's truly a win-win. And from a product perspective, where we began, of course, was in the field of protective packaging, which is our most mature product. In this instance, we call this technology mycocomposite. And so here, just reach behind me, we use agricultural residue. And in essence, what we're leveraging is mycelium's innate ability to bind things together. And so in this instance, over the course of just 4 days, we mix together some agricultural residue and some mycelium, and we grow it to its final geometry at point of harvest. we've extended this technology into a number of different areas. One area, we have partners in Europe that sell things like building construction materials. Actually, right to the side of me, I'll just shift my camera over here. You can see some acoustic tiles. This is a product that's sold both in North America as well as throughout Europe. And then we have opened up this technology, again, with our initiatives to democratize through grow-it-yourself kits, which today are distributed in North America, South America, and in Europe. And the intention there is that if you're trying to get into an industry like plastics, the likelihood that an individual is going to buy a twin screw extruder and put it in their garage has a very low likelihood. But someone, even as young as someone in elementary school, can take our grow-it-yourself materials and grow their own custom molded products within the home, classroom, or a design studio, which is fantastic because, again, it helps expand the process learnings because we're working against a century worth of process learnings in the field of plastic, as an example, as well as allows individuals to explore other markets that Ecovative isn't focusing on. And so for us, that has spawned small businesses that have come out of the interiors and furniture industry. Organizations that make surfboard cores, as an example, which are plastic foams. Taxidermy inserts for things like birds, which are typically polyurethane based. And so the breadth of plastics is really broad, and that has really helped, again, multiply or increase the impact that our technologies can have. Concurrently, what that has allowed us to do is to start to explore, as a research organization, the other important implications of mycelium as a material. And from there, we started to develop materials that were just mycelium. Back in 2011 was when our initial exploration started, because our protective packaging products tend to be very stiff and rigid, whereas there's lots of applications for plastics that require elastomeric properties. So we started to develop a material at the time that we call MycoFlex, which is a pure mycelium product. Different platform, so when we harvest it, we just get mycelium out of it. And by changing the species that we use, we can get very unique material properties, yet again, because just like you and I are individual humans, each individual type of fungus has its own type of properties and values that it can provide. And what that technology has allowed us to do is to extend our reach into other fields, the first of which we started in 2020. So as an example, we have a sister company called My Forest Foods, which grows gourmet oyster mushroom mycelium and transforms that into alternatives for whole cut or whole muscle meat products, inclusive of alternatives for pork and beef products today. And so they're able to deliver nutritious and delicious products that are competitive with conventional meat at consuming a fraction of the land, water, while delivering the same type of nutrition. And this, again, is reliant upon the inherent structure of the mycelium, because that's what provides the texture or mouthfeel that people have come to expect out of conventional meat products. And we're taking that same technology, adapting it to inedible strains, mushroom species that are so tough and tenacious that you really wouldn't want to eat, even though they aren't harmful. And we've extended that into areas like textiles, again, elastomeric foams. And we see opportunities beyond that in additional structural materials that could be used in transportation technology and beyond. And so we see that as our next future step as we continue to demystify and unlock the potential of structural applications with mycelium.
That's just amazing for me, Gavin. Just the depth at which you guys have gone. And when I say that, it's when you talk about different species, and I know, having spent time with you and you talking about, things being soft and things being brittle and things being hard, and the interplay between fibers and mycelium, the kind of work that has been explored on that side. Just to segue towards more packaging, because that's where our work is sort of, even this podcast is all about how do you scale that. Are there other, if you think about the pure mycelium ideas that you're talking about in terms of leather, do you think that's a possibility to expand into the packaging space more, because that's much more flexible? And of course, a lot of packaging, a lot of work that we see happening and needs to be explored as the flexible packaging side. But of course, there's a huge amount of barrier properties that are needed. Do you see mycelium adaptation in that area? Because you've already gone towards leather, you've gone towards textile and fashion. So is that something that you think can be done at scale and effectively?
I do believe that over time it will be available at scale and in applications such as protective packaging. The reason why we're focusing in areas such as food or in textiles or elastomeric foams that are used in apparel is that the value that those products command tends to be higher than that of conventional plastics. And one of our experiences over the last 15 years has really been that although there is increasing interest in sustainability, when it comes down to making a sale in protective packaging, as you know well, is that it has to be an economically competitive product in order to move the needle. And so for this technology, yes, I do believe that we will get to a scale where it will be economically competitive with incumbent products, like polyurethanes or ethylene vinyl acetates that are used in the market today. And then from barrier properties, one consideration is the product's always opaque, so I don't think we'll have a translucent product in the near future. But mycelium has a number of interesting characteristics that I think lend themselves nicely to barrier attributes. So one, it's an open cell product, which means that it does breathe, unlike a closed cell product, which a urethane or an EVA would do. So it does allow for gas exchange at a specific rate, while also being naturally hydrophobic. So within nature, fungi produce an aptly named protein called hydrophobin, which means that they're inherently water resistant. So they'll bead and water will roll off because it produces a surface that's super hydrophobic in a sense. And then the last thing that I'll note is that because of the structure of mycelium, which is inherently a hollow fiber that's interconnected to create this pore space, it also offers really interesting insulating properties that are very competitive with conventional plastic foams, where if there is a need for thermal protection in transit, I think that is a meaningful opportunity where a lot of plastic foams are used today that could be explored in the future.
That's amazing, and it's sparking all sorts of good ideas in my head. But taking a segue, one of the things that really inspired me, Gavin, with the work you did, was on the process side. We talk a lot about biomimetic design, and you can have all sorts of examples there, from Velcro to the bullet trains, etc., etc. But the materials are still built with heat beat treat. So it'll be wonderful to hear more about your thoughts on biomimicry and how you've utilized that on the process side as well, and how would you think that could be replicated in other domains?
Yeah, I will note that my view on our process or product in biomimicry is that we're always biology, not biomimicry. But to hear how you've scoped it in terms of defining our process in cultivating materials, you're exactly right. It is a biomimetic process. And what we do here is vertical farming. That's in essence what we consider it. So fungi are what are known as modular organisms. We're unitary organisms, meaning that unless we have a mutation, we're going to have 2 eyes, a nose, 10 fingers, 10 toes. The interesting thing about mycelium is that they respond to their surrounding environment. So similar to how plant may grow toward light, fungi, light is one stimuli, they have a whole family of environmental stimuli that help dictate their growth characteristics. And so what we have been able to uncover over the last 15 years are what are the right environmental stimuli that allow us to either tell the fungus or coax the fungus into believing that it's under the ground. So it starts to bind our raw materials together in a nice tight weave. But the other thing that we want to do is have a nice soft texture. And so that means that we need to tell the fungus that it's growing on the outside of a tree and to start its preparation for growing aerial mycelium, which is what gives us a nice white aesthetic and a very soft touch. And so those are processes that we have both identified that are innate to the fungus. And what we are doing is we're working with the biology of the mycelium, but we're simulating an environment that helps coax the product conditions that we want out of it over a short period of time. So we're working with wild type species that we've just went out and isolated or captured from the wild. And we're working within that organism's environment to then create the products that we want day in and day out on a consistent basis at an industrial scale. What I'll notice is that we've had to do this in other geographies as well with partners. And one partner that we have is based in New Zealand. They're called Biofab, and they grow packaging. And of course, we could not transport our strain into New Zealand. That's a biosecurity issue. And similarly, they have a different environment than we do here in upstate New York, or our partners do in northern Europe. And so we had to, again, explore in partnership with that organization, how do we identify the right species for that region or geography, and what are the unique environmental conditions that that organism is used to growing in. And so it's something that is duplicable, not just to our individual strain that we use for packaging, but to other species around the world, which lends itself quite nicely to distributing this technology and fostering new partnerships.
So you talked about trees, for example, and they're growing in a certain structure. One of the things that's excited me, mainly because probably I come from a cellulose background, is that when I look at trees, they are, again, so magical because it's ultimately carbon from the air, it's photosynthesis. So, picking your brains, do you think at some point we could photosynthesize fiber?
First, I think that possibility does exist. What I would challenge is whether or not a tree is the right vehicle to produce the scale of fiber that you're looking for. So trees are really amazing because they can produce these long vascular fibers, right? That's what makes them a tremendous product for plywood or wood that we use. Whereas there are other types of plants, be it microalgae as an example, that too photosynthesize. So they are capturing the same carbon dioxide from the air and have the opportunity to too produce small molecules. And cellulose, depending on the molecular weight or size of the cellulose that is of interest, is something that could be produced in a microalgae opposed to being produced in a tree. Similarly, there's our cellulosic products, nanocellulose as an example, that can be produced in bacteria or within a cohabitation of multiple species. One that I think is always quite interesting is a SCOBY, which is a symbiotic relationship, of course, between a yeast and a bacterium. And they too are known to be producing, in some instances, large molecular weight cellulosic fibers that could then be transformed into other downstream products. That could be something that gets post-processed and transformed into a paper product, or it could be something where, again, has the unique attribute where it provides some self-assembly. And so I would marry the scale of what you're targeting to the right organism. Rather than trying to engineer something that's a tree that would fit into the same processes, then you're just going to go back into the same process steps that you might from, say, the pulp and paper industry. And I know that your company has been fantastic at taking highly abundant byproducts like bagasse, if I'm not mistaken, and using some conventional processes to be transforming that into a new higher value product, which I think is amazing. Because the longer we can let trees continue to sequester carbon, the better off, I think, for everyone on this planet.
Yeah, and also it's challenging for me to see the monoculture farming. Otherwise, the whole biodiversity goes away. Even though I would say, at least in India, I see paper companies growing more trees than harvesting, but it's all monoculture. That's not the way nature has designed things. But it's still a big challenge for me personally and us as a company in terms of process. Like what you have done is hacked the process and made it much more kinder and gentler. And when I look at ours, and you mentioned the word conventional, in the end, it's taking a harsh chemical, caustic soda in this case, and then, using different solvents, which are not really water-based. So the other thing we have been exploring is enzymatic routes and seeing how we can use nature's inspiration again to change our processes. Would you have ideas around that?
I'd approach this from a couple of different angles. The first angle I would approach this to is, what is the relationship to time? Because if you can employ biology through a fermentation process, and I'm just thinking of a different fiber entirely, right? If I think about how jute or flax fibers have been extracted from the pith or the core of the plant in the past, that has historically been a biological process, which was something that you would set, forget, let biology exactly do the retting on your behalf.
Retting.
But it takes time, right? So that's something that you have, in essence, biological work in progress sitting in inventory for a period. The other thing that I would call into question is uh, why are those types of chemicals truly needed
Yeah,
in the
yeah.
first place? Is it because you need to uh, uh, remove pigmentation and color to have a consistent product? Is it to ensure that there isn't any other microbial activity? Well, if you start with why you're doing that, if you go back to your first principles to say, okay, well, what is the product that I truly want? And if I target the production of that inherent product in, say, a microbe or in a different plant, as an example, can you eliminate the need for those processes just by selecting or designing for the right fiber in the first place? And so, for example, if I were to think of other types of nanocellulose or biocellulose products that I've seen from microbes, they don't need to go through a bleaching process. They don't have the pigmentation that is just inextricably linked with the plant that's grown. Because the plant, of course, has evolved to produce pigmentations and colors for lots of different purposes, be it to attract pollinators or to make something that's robust to UV radiation, things of that nature. But that's not important for the end goal of a packaging product, as an example. So those are just two ways that I would frame that particular question.
The other interesting thing which you mentioned earlier, and is super important when we look at really impacting the kind of damage us as humans have implicated. And I find that that can only happen if we are able to do things at scale. What I see is still it doesn't happen in millions of tons. We made a little impact and it's a great idea, but the real dent in that pile would only happen if it is significantly scaled. And I know you've looked at cost effectiveness and scaling, but I'd love for you to talk about how do you see that in terms of the amount of materials that are needed to be available to the customers to actually make a shift.
I think what we have learned over the last 15 years is that there is an appropriate scale for an individual operation. As an example, the second plant that we built was a very large scale facility that was based in Iowa. And that scale of operation required us to also amass a tremendous amount of agricultural residue at any given time, which was cost that we had to incur in terms of storage. That was a challenge and an added cost that we didn't anticipate at the time. What we have done since then is we have created, in essence, a duplicable unit cell that could be translated anywhere in the world. And each one of those organizations moves typically somewhere between 10 and 20 ton of material on a weekly basis. By decentralizing, that has a number of distinct values. One, decentralizing means that the local agricultural residue can be valorized through the process, and we can reduce the transportation energy as well as the need to inventory and store at any individual location. That's incredibly powerful. The second is, as you know well, when it comes to protective packaging, you truly don't want to be shipping that a great distance. That carries cost and additional embodied energy. So through a network of medium-size manufacturing facilities that are strategically located near manufacturing hubs, we can create serviceable regions, typically about 800 kilometers, that can be served by an individual operation that doesn't carry a tremendous scale, but is sufficient for meeting that particular market demand. And so our approach has gone from going as large as possible in one individual centralized location to stepping it back, which also had a meaningful impact on capital equipment, so the expense to start up a facility. And we've seen a lot of value in that. That's something that is relatively new for us. We've been doing that for about 5 years now, but we've continued to grow in terms of partners, and it helps multiply our impact while allowing smaller organizations to reach the end customer within their region.
Yeah, and I think that's wonderful because the whole idea, again, in a way, it's taking a cue from nature and biology. It's decentralized. Naturally, because of the way we are conditioned, it sort of feels like, we need to build this big behemoth of a unit and then, try
Very
and
much so.
do everything there and then export out. And that in itself, you're right. There is a lot of energy that gets utilized in transportation, but if you can locate smaller units, then that would create a bigger impact in terms of scale, but also in terms of lowering the carbon intake. So I think that's a wonderful thought process, and I think again very much nature inspired. It seems. Are you able to compete on cost, or it's still from the perspective of the customer being ready to pay a little more?
We can be cost competitive, and we focus our efforts on custom molded alternatives to plastic foams,
Okay.
where our true competitor are the plastic foams that we'd like to displace. Those tend to be more complex and more expensive
Yeah.
pieces
Yeah.
as well. And
Yeah.
the cost volatility also tends to be pretty dynamic, given, again, the coupling to fossil fuel prices. And so for us, we focus first in a number of fields that we've learned are most addressable for our product. And two, always on custom molded geometries. So the areas that you will see oftentimes our products being used range from, so e-commerce has been a big uptick for us, packaging things that are fragile and delicate. These are range from glass bottles and things of that nature used in food and personal care industry, all the way through to various types of electronics, because our materials are dielectric, all the way through to, again, very heavy goods, where you might use a tremendous amount of plastic foam, where the mechanical properties of our product really help and provide additional value, where we can eliminate some of the additional packaging that would be used in something that is not as strong, like an expanded polystyrene, or something that might have been a marriage of expanded polystyrene and wood, as an example. And so I'd say that the custom molded area for e-commerce, as well as for heavy goods, industrial products, furniture, that has always been perfectly aligned in our wheelhouse, and we tend to be very cost competitive within those spaces. Because again, most organizations aren't willing to pay more for protective packaging, because again, it's secondary to the product that they're truly selling.
Gavin, when I look at you as a real creator and somebody who's always got these ideas. In an organizational sense, how do you separate yourself from this day-to-day rut of business and selling? Are you always just creating, or are you also building these business, or does Eben look at that side? How do you guys do it?
Yeah, certainly. I'd say, well, you have to do both, truly. And so for an organization to succeed, you have to be able to focus.
Yeah.
And so I'm in a role where I have an opportunity to be distracted. It's actually my job to be distracted. If I'm not going out and learning about other opportunities and identifying whether or not mycelium could be a meaningful benefit for those opportunities, I don't think I'm doing my job, because I have to be forecasting and looking out at what's next. But with that said, I need to protect my team from the distractions out there, because of course we believe that our materials could fit into lots of different applications. But in order to be successful, focus has to be on scale for those products, getting them to the market and meeting the requirements of customers so that you can make those repeat sales. Otherwise, you're not going to have an impact. So from my perspective, I like to really do two things. I like to learn, where I can have conversations with industry leaders, understand their pain points, understand what they're forecasting into the future in terms of what both their customer and business needs are, and see if, again, mycelium might have performance attributes that could uniquely serve that space. And two, and I love to teach, because oftentimes the world of fungi, mycology, is really not understood or misunderstood by the general population. And so I have the unique opportunity to educate on fungal biology, material science, and the unique things that we've discovered over the last 15 years that could be applicable, maybe not today, but to a market category in the future. And that transcends to not just different products, but to different markets and things of that nature, which is always exciting for me to have the opportunity to both learn and teach.
So how many products do you parallelly work at? Of course, there's such an exciting field, but do you restrict yourself that, okay, I'm going to look at these five right now, and I'm going to try and take them to a certain level and then move to the next one?
It is, and I'll tell you, this year, our business is focused in a couple of different areas, and they're business units, so they have dedicated teams that can focus on those particular strategic initiatives.
Yeah.
And so protective packaging is one, and we are growing that business both through partnerships in Europe primarily, as well as, again, here on the East Coast. So we're setting up another packaging line here in New York. And so that's one area that the team is building out those assets to begin operations relatively soon. The next is demonstrating our aerial mycelium platform for food. So in collaboration with our sister company, MyForest, we are building the largest of its kind aerial mycelium farm in the world. And that'll begin commissioning in June of this year. And we have other large-scale farms that we've been operating that help de-risk that particular process, which has been incredibly powerful for us. That underlying technology demonstrated in food is then translatable to other markets. So our research team is now deeply engaged and focused on developing the next generation of mycelium, not for food, but for elastomeric foams and the like. And that will be something that then, in sequence, comes after food, once that is fully commissioned and at the commercial scale that we expect it to be next year.
That's very succinct. It's not as diverse as I had thought it would be. It's pretty much clear that okay, it's productive packaging, food, and then maybe the more flexible options. And within that, I'm sure there would be different materials that you'd look at.
And there's lots of opportunities still for mycelium that are out there. We're always testing things to see what might be next in that sequence of events. For example, we have a cellular scaffolding for tissue engineering that could be used in the medical field. We launched that under a brand called Excel Bio. It allows us to collect data and voice of customer feedback to inform future development. It's not something that we actively promote, but it's a way that we can test whether or not there's a good product market fit. And to get that feedback from the customer, that helps then drive our development programs to ensure that we're delivering a product that is of value to the industry.
That's wonderful. I'm going to start taking it towards closure, and I have a couple of questions that would help all the listeners learn more. So Gavin, who have been your inspiration, apart from your parents, who you mentioned in the past, and who are the people you're seeing as co-collaborators or people who are bringing change to this world of materials and packaging?
Well, in terms of major impact on my life, I'll go back to actually where it started with a professor that we had in a course called Inventor Studio, Bert Swersey. Coming into engineering school, entrepreneurship was never top of mind.
Yeah.
Right. I thought that I would join an organization, I'd have the opportunity to design and hopefully make an impact. What Bert did as an individual not only inspired us in his class, but he was an incredible mentor outside of the classroom, continuing to push us to ensure that the things that we created did indeed have a positive impact on our planet and were something that were accessible to as many people as possible. Continuing to press and question the decisions we made, not just from a business perspective, but from a societal perspective. Does this truly hold value for the world? And the other aspect I'll notice is that he was incredible at promoting and pushing us to explore the field of entrepreneurship and to do it ourselves. Because we could always go into a business elsewhere and potentially have an impact. This was our opportunity to really control our own destiny and to do what we thought we could to serve the world. And so he was incredibly impactful for us, continue to use his insights and guidance that he served us, and a number of the individuals that work in our organization came out of his classroom, as an example, to continue to drive and motivate Ecovative. And so Bert Swersey was an amazing mentor. We unfortunately lost him a few years ago, but continues to be deeply instilled within our organization. And then I'd say in terms of those that are doing incredible things for the world, I will say that biotechnology truly is here, and there's a diversity of organizations that are looking to address everything from our plastics pollution to agriculture, once again leveraging biology. And these include organizations that are focused on synthetic biology, maybe not organisms that go out into the world, but those that are engineered to produce molecules that we would typically extract from fossil fuels. Those organizations, I'd say I'd elevate Checker Spot is one that I think is incredibly motivating and an amazing organization that's making alternatives for polyurethanes and performance sports goods and the like. I think they're an absolutely outstanding organization, always inspired by the likes of Ginkgo Bioworks and the cross-sector activities that they do in a wide range of fields, as an example. And then I'm seeing lots of interesting things in the packaging space that do relate to new materials, either extracting chitin from crustaceans and creating new types of foams, or using cellulosic fibers in unique ways to, again, create foam alternatives or the like. That I do believe that if we're going to move away from our addiction to fossil fuels, it has to be a family of products. It's not going to be an individual solution. And it takes a broader community to bring these things to market and share experience so that we can all grow together. And I do believe that community is ever growing and with us today.
That's truly amazing, the kind of width you've provided in terms of people doing interesting stuff. And I, again, like you, I've been super interested and amazed with this whole microbial multiplication domain, and the potential that it holds in terms of building unique materials. Modern meadows is another one, which I'm sure you know well. My last question to you: so, what does the idea of good garbage mean to you?
Well, I think you said it there in the question. Almost is that in our surrounding environment, in the ecosystem, there truly is no garbage. That garbage is the resource that spawns new life. And that's precisely how we should think about even the byproducts of our industries, is how can those be transformed into higher value products that are either more durable, but also provide a benefit not only for society, but for the planet. And I also think that the way that we think about garbage is that we today amass it in individual locations that then become burdensome to future generations, rather than thinking about how could we design them so they have a secondary life immediately after their primary function or use. And I think that we're starting to see how materials and products are considered, to start to integrate that through reclamation programs where things can be either repaired, cleaned, sold again, because they still hold value, and they hold more value typically in the form that they were created in, opposed to downcycling them, as an example. Considering how things can be returned to the earth where it is appropriate. And then finally, I'll note that I think that we're also seeing a change in how we buy things generally. So if I think about, going back to what you said earlier, when you were younger, you didn't see much packaging. We really went through this process where everything had to be packaged. And in some instances, I can go to the grocery store and I'll find individual produce packaged, which I don't quite understand. But seeing a lot of reusable containers come to the fore and becoming part of a societal norm, which does take a meaningful amount of time, I think give a lot of hope and promise to displacing and then also informing how we design packaging in the future.
Yeah, I think I agree with you. It's like, I think no packaging is the best packaging in the end. Thank you, Gavin. It's always so wonderful to speak to you and get your insights. And I'm so happy. In a way, I'm happy today to have started this podcast. It's inspired me, and I'm looking forward to hearing from people how it inspires them. Thank you, Gavin. Thank you for being here again.
Oh, my pleasure. And thank you very much for the opportunity.
Thank you so much for listening. We look forward to bringing you more and more ideas with guests in the coming weeks. Watch out for this space.